Okay, good. I just wanted to just a couple of words about Project One. I looked at the debriefing and I posted sort of a response to that. I won't spend too much time talking about that now, but just a reminder that for the next debrief, the peer evaluation, I rely on that to sort of justify that everybody's, or to verify that everybody's doing the same amount of work. So it is important to submit, and it's part of the project. It has to be done. So I wanted to reiterate on that. What some of the feedback I got on the optional part of it on the survey was, it was things I kind of expected, that I could have provided more direction and maybe provided better context. And part of what I like to do, for better or for worse, is to give you a lot of space to kind of figure things out on your own. I think that's a productive struggle. And I know I can err too far on that. So I'll try to keep that in mind and not, not overdo it, to give you a little bit more direction. But at the same time, I rely on you to come with me to questions. That's the only way I really know that I need to do more. So if I'm not providing enough direction on a project, please, bring it up either in the meetings that we have, or, we can talk about it in an office hour or by email. That's an important thing. But one thing that I think was a good point that somebody made was that it would have been better had I tied them together before everybody presented, and I can understand that, and I think there's validity to that. So one of the things I'm going to try to do this class and on Thursday is to work more at providing the context for what your presentations are. And kind of what I expect the arc of that to be is there will be some confusion in the beginning as you start to figure stuff out, because some of this stuff is alien. I really want to help you figure it out. And so that's kind of, I'll do that to the best I can. And then gradually it'll start to make sense. And I want you to have agency in your presentation. So I want you to be able to do it in a way that you feel comfortable. So I'm leaving room for you to do that. And again, you can, I thought the ways that presentations went last session were really good. So I don't have any complaints about those. But again, I'm happy to talk about all that stuff individually with groups. So any sort of responses to that before I go on a little bit? I found the feedback really valuable. And since I don't get that feedback we get naturally in person, that it's really, I need to hear those things. Okay, for project 2, again, it'll be due 10/8. We'll devote all of Thursday to that. If we have time today, we'll break into groups at the end. I need to leave by about pretty much when class ends today, so I can't stay late today. And then next Tuesday, we'll kind of see where we are about how much time that we devote in class. And then, so I wanted to mention that I'll have the problem set out very soon, and that will be due the class, so 2 weeks from today. And I know it's out a long time, and I'm hesitant to do that, but it gives you time to manage the work. So I want to make sure I do that. Okay. So questions or comments about that or anything else before I go on? Okay, so today in the handout section for week 6, there's handout number 8, and I just put it up there, and I'm sorry I didn't get it up there early, and that'll be the guide to what we do today. I'm going to spend a fair amount of time introducing it, and that has the questions when we break out about I want you to do. So, and we'll wait a few minutes before I break out, because I want to make sure that we understand the algorithms. And I'll also give you a little bit of time right now to download that and do what you need to do. Okay. So again, we're talking about the Pythagoreans and the time period, roughly. I guess I should do it since everything's backwards, BCE. It's like the negative number line. This is the time period that we're looking at, and we're looking at the Pythagoreans, and as I mentioned in the lecture, the video lecture, that they were sort of a math cult. They were a group of people that certainly had religious and mystical beliefs, certainly had political beliefs, but also somehow math was a central part of a lot of it. And so, and we don't know exactly how. It's interesting that even by when Aristotle was writing about them in 300, roughly a little bit before 300, so in the late 300s, that there wasn't even a lot of information then on them. They're supposed to have really not much survived even in ancient Greece. So even 200 years after that, there was some uncertainty about them, and nothing really that I know of. Maybe some potsherds and things like that, but no documents. So we don't really know a whole lot about them. So a lot of what we hear is from the stories that people told after. But we do know that they were interested in mathematics, and they were, they had the belief that all is number, and I'm going to personify that today, at least I hope, and that this means that something like a square is a number. We might think of a square as a geometrical object, and we might think of a square as a number like that, but we might think that and this as different objects. But they thought of them as similar. And so what they used is something called figurative numbers, and you'll have a presentation on that. And they envisioned things like pentagons, hexagons, triangles as numbers. And so I'm going to talk about square numbers today. And it's thought, one thing that the person that first introduced me to the Pythagoreans talked about was there was some thought that what they did is they used manipulatives to represent numbers. Numbers are whole objects, and so they're really, so if you have 5 pebbles, you have 5 numbers. And they lived, near the shore, so it was thought they had access to lots and lots of small rocks, and that they could sit around and use the rocks to do math. And so that's why I'm calling it pebble math. And some of what I'm doing today, I'm trying to recreate that. When I do this in class, I usually bring in a bag of pennies that I have, like I have hundreds, probably maybe a couple thousand, and let people look at them, and they create figures and shapes, with some direction. And so I'm going to try to do that today with pen and paper and document camera. And so I'm going to write a square, and this square is made up of 4 dots, and these could be pebbles, they could be numbers. And so I think of these, trying to think Pythagorean-wise, I think of that square as made out of atoms, and the numbers are the atoms of that square. These things represent numbers. So when they talk about all this number, they mean literally the square. And then if I want to make another square, I just add this shape here, that kind of L-shaped or whatever, I don't know what shape to call that, is called a gnomon. And what a gnomon is like if you imagine the square and you cut part of it out, what you have left, that's one way to think about a gnomon. So when I added these 1, 2, 3, 4, 5 pebbles to the 4 existing, I get a new square. And again, this seems kind of trivial, but I'm making a point that we will use later, that I'm going to add another gnomon, and I'm making a new square. Notice I added 7. So there's 7 to the existing square, makes 16. So again, these gnomons, they must be odd. And why is that? Why must they be odd?
two equal sides and then the vertex.
Yeah, exactly. You have to add that odd one there to complete it. So I'm thinking of this when I move from one square to the next square. I'm thinking of I called it completing the square, which is a little bit, that's not totally accurate, but you're making a new square. Okay, and to do that you have to add an odd number of those, and that becomes important. So think back to the Pythagorean theorem. A squared plus b squared equals h squared. And we're thinking of all these things as natural numbers. We're not really thinking of like 2.3 times 5.8 squared, not things like that, but natural numbers. And we create, so an A, B, and H is a triple because it has that relationship. And notice that if I multiply A, B, and K, I'm sorry, H by K and square them, we did this last class, I get a triple, but this is not considered that's not a new triple because its atoms are still A, B, and H. So that's not a new triple. It's just a version of this triple. So if you've had one-on-one, I think of these as equivalence classes of triples. They're the same triple. We think of them the same for an essential reason. And even though they're strictly speaking not the same, not equal, they're equivalent. So it's an example of an equivalence class to me. Okay. So the goal for the Pythagoreans is to create triples. I'm taking some liberties. We don't know for certain because we don't know very much about them, but they did create the Pythagorean theorem. A lot of mathematics is attributed to them. They were thought to have very, interest in number theory. And so that's kind of what we're doing, is developing some elementary number theory. So here's the question. I want a square, and then I'm going to add a gnomon, and I get another square. And if this gnomon is a square, so square 1, square 3, if this gnomon is also a square, in other words, equal to 9, equal to 16 to 25, if that's the amount of dots that I'm adding, then I'm getting a triple. So here's a good example. We'll start with the square that is 4 by 4. And then I'm going to use X's to indicate the new things that I'm adding. 1, 2, 3, 4. I need that odd one there at the vertex. And what I have is a new square. So that square is 16. This square is 9. And the total square is 25. So I have a Pythagorean triple. So I have 4 squared plus the square that I add is equal to the new square. So does that make sense? And this is actually a physical thing. And the reason I'm thinking of it as pebbles, because you could actually do this and see this. And if I wanted to take this, I could arrange it into, I could take all those X's and arrange them into a square. And again, so there's this sense that they thought of these square numbers as actual squares. And so how do you show that this is a square? Well, you turn it into a 3 by 3 square. That's how you do it. So again, that's why one of the suppositions is that they used, pebbles as ways to sort of visualize these things. So, any questions about that? So you tell me, how do I use this idea to generate Pythagorean triples? I just want to make note that this triple is 3, 4, 5. Or 4, 3, 5, if you want to think in terms of the order. How can I use this idea to develop new triples? That's one question. And then how do I algebraicize it, which we're going to do so we can understand it better. So
Would
how can,
you
oh, go ahead.
just make escalating squares and then add the gnomons onto them to make them bigger, and then see if the gnomons are squares as well?
Pretty much, but why don't we invert that? What's the next odds? Remember, these have to be odd numbers, right?
Okay, so what you would do, what's the next odd number of
So we just added 9. So what's the next odd number?
11?
That's a square.
That's a square, 25.
Yeah, okay. So again, I'm adding these 25 here, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then I have 12 down here. 6, 7, 8, 9, 10, 11, 12. And then, so what's this is my outer square. What's the inner square inside here?
It's going to be 12 by 12.
12 by 12, because I just noticed that this is 12, 12, and 1. So I'm going to add, I'm not going to do it. I'm just going to write a box down.
You're not going to draw 144 dots?
I'd love to, but. So imagine that this is a 12 by 12 pebbles, okay? And again, I'm guessing in elementary school, if they're learning triples, they would actually use 144 pebbles, but as they got older and more abstract, they would probably just draw, if you imagine doing this on a beach in Greece, which sounds pretty nice, or actually they were in southern Italy, around where the heel is. So in the Mediterranean, on the Adriatic, really warm. Imagine being on a beach and sandy, and they could just draw the outline in the sand and put rocks on the outside. So I've created a new triple. I have the small squares, 12. The gnomon, I added 25. And then my new square is 13 by 13. And so obviously that 25, I'm going to write it, it's a square, so I'll write it as 5 squared. Again, imagine taking all 25 of those and assembling a square. If you have the question, is this set of pebbles a square? You can answer that very visually. 13 squared, sorry. So I have a new triple, 5, 12, and 13. Okay, so what I want you to do is to generate a bunch of triples. I'll let you go, I'm just gonna form random groups in a minute, and I'll let you go do that. But on the handout, I say do this up to odd squares up to 169 if we have the time. And we'll just see whether you have the time or not. So, you just generate this before. And then think about what I did is I started with the square, the gnomon, I'm sorry. And then I figured out what square fit inside it. And then notice I have a bigger square on top. So and also let's just, before we go, let's figure out a formula here. So if I take my 12, that's going to be x. 13 is x plus 1. Because I'm only adding a gnomon that's, that's one deep, let's say. So I'm taking x squared, I'm adding another square, and then I get x plus 1 squared. Again, we're doing this by algebra. So I'm going to solve for y. Y squared is equal to x plus 1 squared minus x squared. What's my formula for y? Or y squared, I'm sorry. What does that simplify to?
Is it 2x plus 1?
Yeah. And what kind of number is 2x plus 1? We're assuming all the numbers are whole numbers. That's an odd number.
Also.
So we're looking for odd numbers that are squares. That's what we did here. We took 25, we did not do this algebraically, but we thought of 25 is equal to 12 plus 12 plus 1. That's how we figured out what the sides were. So what we did sort of intuitively is right there. And our question is, what odd numbers are squares? And we can identify those. Okay. And then each time we do this, we've generated a triple. And one more thing before I put you into groups. I talked in the video about the doctrine of odd and even. And I don't know how many this is. I'm trying not to count. Okay, so I want to know if I have an odd number or an even number. So what I do is I take these and I start to line them up 2 by 2. So I've done 1, 2, 3, 10. So I've done all these. I've done this one. I take 2 more. I've done those. And now I've lined these up. I'm just using X's as marks. This pile was odd. So one of the ways, they had this doctrine of odd and even, where they knew things odd plus odd is equal to even. And it's thought that they could sort of take a pile of things and determine if it was odd or even, all is number. And then once you know, then how would you show that odd plus odd is even using these pebbles? Well, you'd have 2 piles. Each odd pile would have a leftover because it's odd. That's what makes it odd. And you add them together, and those 2 leftover things make an even number. So it's thought that they actually tried to prove these things, and the way that they would prove them would be by manipulating these pebbles. Okay, so it's actually, again, doing this, it's an exploration. So I wanted to mention that. And you can do this odd times odd is odd. I mean, you could go through all the doctrines of the even and odd and prove them using pebbles. Okay. Okay. So back. So when you look at number 1, you have your algorithm. You're going to find odd squares, and you're going to generate a triple. So I'll break you into groups where you do that. But before you do that, any questions? I don't think this will be hard, but I want you to think about some other questions, which I mentioned on for number 1. And then we're going to go back and do this. We're going to amp it up 1 and generate a whole nother set of triples. Okay, so I'm going to form the rooms. Hey, Nick, I'm just wondering if you're having a problem joining the room.
I think so.
Okay.
Oh, hi, sir.
Hey,
What are we doing for 1A though? Or did we already do that and I just wasn't paying attention?
I think that's kind of what he was trying to show in class with
Right.
the drawings of the squares.
Okay, that makes sense.
just understand how you do it. And then, we'll use algebra to do it just because it's easier. But
Generate triple.
understand that you could do this using the pebbles if you wanted.
Ah.
Okay.
So generate triples using odd squares of 16.
I just want you to go and do it up to 169, or I think you'll have time to do that.
Okay.
But any questions?
I think we're good for now.
Okay.
Thank you.
Okie doke. Hello, I'm just checking in to see how you all are doing. What questions you might have.
How high did you say we were going up to for this?
Oh, look at part B, 169. Just to,
Okay, yeah, there it is.
just to get a list and use these to try to figure out why. Use that list to sort of understand C and D.
Okay.
And that first part, that's just what we did. Just want to make sure you understand that. Yeah. Okay. Sounds like you're doing okay. So I'm just going to go look at the other rooms, and if you have any questions, just ping me.
Hi, Dr. Alexander.
Hello, Daniel. How you doing? How's everybody doing? Good.
Not bad.
Good. So I'm just seeing if you have questions. And by the first part, I'm just, somebody asked about that, and that's what we already did. Just kind of want you to understand how that works.
Yeah, so we just need to skip to generating triples up to 169.
Yeah. And then use the ones that you make to try to figure out, I think if you just see the set that if you generate a few, I think you'll be able to see the pattern, and then you can better address like C and D.
Okay, yeah. Yeah, we haven't really started to work on it. We also had like a bit of a debate on what to do, but yeah.
Okay. Does that help, what I said? I hope.
Yes, it does.
Okay, good. Okay, doke. Okay, so I'll see you. Just let me know if you have questions.
Yeah, thanks.
Just coming in to say
Hello.
hi and see if you have any questions. Just make sure you're on track.
I th hmm.
So when you do a few of these, I think for part B, when you generate them, I think you'll see the pattern, and I expect that you can use that pattern to answer C and D.
Okay.
Okay, doke. So I'll just let me know if you have any questions. I'll let you work. I think this should be pretty cut and dried, but if you have any questions, don't hesitate to ask. Okay.
Sounds good.
See you in a bit.
Um,
Hi, sir.
Hello.
On for part B, did you want us to go up to like 169 squared or
Oh, no,
13
no.
squared?
No, just odd squares up to 169. Yeah.
Okay.
So 13 squared. Sorry.
Okay. That's
Yeah, why don't you
good.
do it up to 169? That's
I was like, if we're gonna spend all class doing this, that's fine.
And it does say if time, so it makes sense.
Yeah. Yeah. So no, that's fine. Yeah, no, I can understand that. So have you gone up to that high?
yeah.
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 So what do you notice about the triples?
They're, well, two numbers are always one apart.
Yeah. Okay. And I think you can use that to sort of figure out C and D. So we'll talk about that in the class, but I figured people would be making progress. So I'm going to go back and just see where everybody is, unless if you have a specific question, which I can answer.
I think we're good.
Okay. Sounds good. Okay. So see you in a bit. I'll probably just call everybody back in a couple minutes. Hello, I'm just sort of checking in to see where you are. And I'm only asking, I'm thinking of 169 as 13 squared. Okay, so you don't have to go all the way up to 3 squared, 5 squared, 7 squared. I'm not asking you to do all the way up to 169 squared. Just up to 13 squared.
I think I got them.
Okay. So what do you notice about this group of triples?
Well, the y values I got, they just kept going up by 2 each time.
Okay.
So 3, 5, 7, etc. And if I understood it right, I got it up to 17.
Uh-huh.
And then the x went up by the difference between the next one went up by 4 each time. So the difference was 8 the first time, and then 12 the next, 16,
Okay.
and so on and so on.
Okay. And that's going to be a reflection of the difference in the squares. But what do you notice about the triples themselves? If you had one sentence to describe the main thing you see about the triples. Okay, and I might be asking, don't think too deeply.
I probably am. I just took a test, so.
Yeah, that'll do it. So how far apart are the biggest numbers?
1.
Yeah, and to me, that's the most important thing, because I think that's the key to answering C and D. Like, how do you know that none of these can be the same? And how do you know
These are always 1 apart, so they can never have the same factor between them.
Yeah, so we'll talk about that when we come back in the class, but that's kind of what I was thinking of right there, with those things. To me, that's the biggest part of it, because it's like, oh, wow, you just get struck by that pattern. Well, I do, yeah. Okay. So I was going to go and visit other groups. I think everybody's made pretty good progress, so I just want to make sure and see if there's questions, but are there questions before I leave?
Don't think so. I don't have any.
Okay. Hannah or Hannah?
I don't have any. Thank
Okay.
you.
Okay, good. Okay, so I'll probably see you back in the main room in a couple minutes.
Thank you.
Just gauging, seeing where you are on the sheet.
We just went through part C and D.
Okay, good. So we're going to come discuss that. That's good to hear. We're going to come discuss that back. I think I just got to check one more group. I think everybody's pretty much made a lot of progress, and so I'm just going to go visit the other group, and then probably in a minute or two I'll call you back.
I have a question now.
Oh, sure. Yeah, go ahead.
So for part C, is it just saying that like if K were 2,
right,
and you times to like the triple 24, 7, and 25, each by 2, it would create a new unique triple.
Well, if you multiply everything by 2, you're creating a copy of the same triple.
Right. Okay.
Right. And so what I'm asking is, why are they unique? Why are they not the same? And yeah, I'll bring that back to the whole class discussion. But does that make sense? Does that answer your question?
Yeah.
Okay. Yeah. Okay. Okay. Other questions? And like I say, I'll call everybody back. I think I have one more group to visit, but I'm guessing they're pretty much where you are. So probably call you back in about a minute. Okay.
Sounds good.
Okay. Bye-bye. Hello again. Miss, where are you? Are you on C and D?
For 1?
Yeah.
I'm done with 1.
Okay. So you're the last group that I visited, but do other people have questions?
I don't have any now.
You want to discuss C and D for a little bit in the 30 seconds or so you have left, because that's what we're going to talk about when we get back to, maybe you already have, but that's what we're going to talk about when I get back to the class. Okay. So I'll see you in about 30 seconds or so.
Okay.
Yep. Good. Bye-bye.
You're on mute.
I started to write the triples. So I got 3, 4, 5. And what's the next one?
5, 12, 13.
Yeah.
Yeah.
And just keep going.
7, 24, 25. 9, 40.
9, 40, 41.
Okay.
11, 60, 61.
Okay. That's enough. Okay, good. And that's one of the ones that's on the table. No, it's one we generated that last class or 2 classes ago. So anyway, so you see the pattern that the big numbers are apart by 1. So how does that tell us that all these are unique, meaning none of them is a multiple of the other?
Because if numbers differ by 1, the only number that they are both divisible by is 1.
Exactly. It's as simple as that. Okay, so we have that. And if I had to ask you, how do we know there's infinitely many?
Because there's infinitely many odd numbers.
Yeah, each odd number gives us a new triple. So it's not that complicated that we get, but we create an infinite class. So I'm amping this up a little bit. Who knows what the Pythagoreans did, but they seem to, from what we know, to be interested in patterns of numbers and things like that. And I think you've noticed that these are unique triples, things like that. And I'm just sort of bringing a little bit of 101 kind of thinking to it. So speaking of 101, countable infinity or uncountable?
Countable.
Countable.
Because you can sit down whole numbers, any set of whole numbers is going to be, any infinite subset of whole numbers has to be countable. You could sit down with enough time and just count them with your finger. Okay. Okay, so we're going to do the same thing. So with the next set of numbers. So what do you think my next step is going to be to create? I want to use this idea to create more triples. I can't create any more that, you know, we could go up to 169 squared and, you know, we could create oodles this way, but I want to get a different family of triples, I hope. So what might be the idea using the same germ? How about
Can you
adding,
repeat the question?
yeah, how could I use this kind of thinking to generate another class of triples? This kind of geometric thinking, starting with the square, adding something, adding a gnomon to it that's also a square, creating a yet more, you know, different Pythagorean triples.
You could choose a different subset of numbers than odd numbers.
And how would I do that geometrically? What would be the geometric procedure with my pebbles? How many rows would I add?
2?
Yeah. Okay, so I'm going to add, if I take 2 rows like this and add it onto a square, rather than 1 row, what kind of number is this? Even, odd, square? We don't know, you know.
Even.
Yeah, because each of them is going to be odd for the reasons that were pointed out before. So for this one, I started with a 2 by 2, and then I added a row of 3, and then I added a row of 4. I'm adding 7 and 9. Oh, wow, worked out. That was accidental. I wasn't thinking about it. I'm not like doing this. So like, it worked, right? So I have a small square that's 2 by 2. I have a big square that's 4 by 4. And then I added 16. My gnomon was a square, so let's see what happens. I get 2 squared plus 16. Wait a minute. I don't know what I'm thinking. No, that's right. My math is right, right? Something I don't like about what I just did. I know what I did wrong. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's my beginning square? It's not 2 by 2.
Is
So
it
3 by 3?
25?
No, the square inside, this one.
Oh,
3 by 3?
that's
3 by 3. I was just not thinking. And then I added 7 plus 9 equals 16. And then my big square is 5 by 5. So let's think about that. So I get 3 squared plus 16 is equal to 5 squared. Well, 16 obviously is a square. Okay, so I didn't get a new triple based on what we saw in number 1, but I don't know. I'm going to try this. I think it might be promising. So I just kind of lucked out into 16. So what would be so I want to think about even squares. So we have 4, 16, 36, 64, 100, and then 144, and then more after that. Okay. So we did 16 and we got a 3, 4, 5. Does it make sense to do 4? If I think of a shape like this that has 4 pebbles, it's going to look like this. Right? 1 and 3. So there's no square to fit around. I mean, I have a trivial one, right? I have 0 squared plus 2 squared is equal to 2 squared. That doesn't tell us anything. That's not very interesting. Okay. So with 4, that didn't really get us anywhere because we want whole number ones. We want non-trivial ones. 16 got us to 3, 4, 5. Let's see what happens when we do 36. So if I add a gnomon that looks like this, that has 36, what are my rows that I'm adding? the total of these two is 36. But how many pebbles are in this one? How many pebbles are in that one? Another question.
Is it?
Oh, go ahead.
No, I was wrong. I had to think it through again.
Right. Another question is, if just I'm just going to do this randomly. If I take 3 and I have 3, I'm not saying this is a square, and then I make a new one. How many new pebbles did I get? Did I add?
17 and 19.
Yes. 3, I add 5, so it's the average. If I go up, if I have one of these that
Yeah.
has,
You half it and take the ones on the either side.
if I want to do 5, sorry, if I have a gnomon that's 5, my inner one, and then I add the other one, 1, 2, 3, 4, 5, 6, 7. So I'm always adding 2 to get to the next one. So this is 36, so it's 17 and 19. So let's see what that looks like. I'm not going to do the dots, but I'm going to imagine that that has 17. This one has 19. What's my inner square here?
It's going to be 8 by 8.
Right. Notice what we did here in the smaller ones. There was 5 here. It's going to be a 2 by 2. It's going to have to fit right in there. This one doesn't count because it's like, it's you know, that vertex we're creating. So it's really, you subtract 1 and then take half. So we're going to have, this is 17 in total. So there's 8 here, 1 here, 8 here. This is 19 total, so it's going to be 9, 9, and that extra 1 right there. So this is going to be 8 by 8 inside. My big one's going to be 10 by 10. I added 36. So I get x squared plus 36 equals 10 squared. Okay. Another 3, 4, 5, right? 6, 8, 10. That's really a 3, 4, 5. So again, this doesn't help. So in the interest of time, let's just do it together. So, but I'll let you work for a little bit. I want you to do this with 64 and 100. And if you have time, 144. So do this process. I'll let you work, you know, but I will sort of be doing it quietly so you can check up to see what I'm doing. But I want you to think about how to do it. You can ask me questions, maybe other question in the chat. Sorry, I missed it. No, I'll get it. Yeah, thanks. So, and I'll do it here. So I want you to start working on this and don't give up. I promise you there's a payoff. But you have to work a little bit harder on this one than we did the last one. So I'm going to use 64. So again, continue to feel like I'm going to go through 64, but if you want, if you know where you're headed, continue to work. But so what I did here was 64 is my next square. I know that it breaks into one less than half and one more than half. So 31 and 33. So I put 31 pebbles here and realized that's 15 on one side, one at the vertex, 15 on the other. And then I put 33 here. So that's 16, 16 and 1. And then I realized that inside I have to have a 15 by 15. Overall, that gives me 17 by 17. And I go through the math and I get an 8, 15, 17. So notice I have a gap of 2, which makes some sense. Then I go back and look at 36 and I have a gap of 2 here, 8 and 10. And then the 6 kind of went in there. And then I went back to 16 and I had a gap of 2, 3, and 5. And then the 4 went in. So this is going to be the pattern that we have, a gap of 2, because we added 2 rows, not 1. So I'm going to ask you to do 100 and 144 next. But are there any questions?
Could you maybe like keep doing this method such that, I mean, now you have like x comma c or whatever comma a plus x plus 3 and just keep up this pattern?
You know, I was thinking about that today. I've never done that. And I was thinking that you probably could. But I think we're going to get some surprising results in there. And I don't know. Let's ask that a question again when we're done. Okay.
Okay.
Okay. But I think you could. I was thinking about that, and I think you could. So the next one's 100. I'm going to add 2 gnomons, 49 and 51. And again, I'll let you work on this. I'll leave that there for a minute. Okay, let's kind of debrief. So, and I can go through any of these. For 4, we got, sorry, I'm going to make sure this is legible, so I have to pin it in a way that I can read it. Okay, good, okay. So for 4, we got a trivial. So I'm not even going to look at that. For 16, we got 3, 4, 5. For 36, we got 6, 8, 10. For 64, we did 18, sorry, that's hard to read, 18, 15, 17. Sorry, I told you it's hard to read, I read it wrong. 8, 15, 17. Then I did 100 on my own, and 149 plus 51. So I put 49 stones here, 51 here, 24, 24, 1. That's how it breaks down, and then 25, 125. So I got 24 by 24 for the inner, 26 by 26 for the outer, and then I'm adding 100. So that's the math, that's the arithmetic. And so the triple I got was 10, 24, 26. And that's what I'm indicating here. And then I kept doing that, and I got 12, 35, 37, 14, 48, 50, 16, 73, 75. And I don't know how far you went, but does this agree with what other people got? At least up to a point?
I think so.
Okay. And again, I've done this a few times today, so I can do it pretty quickly. 144, 12, 71, 73. That's, but then you, let me look for 144. I might have, yeah, sorry. Keycut is right. Okay. Yep. Okay, good. So here's what I noticed. For 100, is this a new triple or have we seen it before? Can we reduce this triple 10, 24, 26?
Yeah, it can become 5, 12, 13.
Right, and we already saw that in number 1. So that's not a new one. How do I know that 15, 17 is a new one? And how do I know that 12, 71, 73 is a new one? That it can't be reduced to a lower triple?
Because the last 2 numbers are prime.
Yeah. Mm-hmm. And this one is wrong. For 196, I realized what I was doing with my mistake. I got 196. Sorry, I got, let me go back and look at what I got for 196.
It's 14, 97, 99.
Okay. And is that going to be a new one? Again, it has to be because that's going to be prime. And then that one to me looks like a new one as well. No, I didn't get that one right. I have to find my sheet for it. I got 16, 147, 149. I know what I was doing in my head that was messed up. Okay, I wasn't really thinking, and I was doing it algorithmically incorrect. I had an algorithm, but it was not the proper algorithm. Okay, so it looks like, tell me what's happening. We are generating new ones, but sometimes we're not. So kind of what's happening here? Like, why didn't we get a new one for 36? And why not for 100? And I guess the question would be to predict the next one that's not new. Well, these are ones we saw. Well, this one repeats this one. And this one repeats one that we saw earlier. So that's going to happen. Some of these we're going to get ones that we saw with the first algorithm. But it looks like eventually we're settling on ones that are going to be unique. We'd have to do a little bit more investigation here, but hopefully you're seeing the patterns here. I don't like this 256 one.
Wait, I'm confused about the 1447. Is that 1447?
196 was equal to 90. 14 is a square, right? 14 squared is 190.
Yes.
Yeah, okay, good.
Yeah, it's
okay.
97, 99.
This is 97 plus 99. And so then I'm going to get 14, 97, 99 for my triple.
What? I'm really confused.
Okay. So let's look at this one right here for the 196. I know 14 squared.
Well, because like I plugged that into a calculator and that's not.
Okay. Well, then I did something wrong then, or okay.
I think you didn't go an extra step deeper. You stopped early.
Okay.
Yeah, I think it's just divided
Your
by
answers
2.
were correct right away.
I'm sorry?
I think the answers you had originally were right.
Right.
Yeah, 48 and 50 are the correct answers.
I did divide by 2, yeah.
Okay. I was worried about that. So 14, 48, 50, right?
I think you did the same thing on 144.
Yeah.
I think you stopped early.
Okay. Sorry, I was trying to rush it through. So let's go back. Sorry to mess things up. I'll fix it just because I don't do a great job when I rush at the end. And so I'll just do the 144 one and then we'll call it a day. And then I'll fix this for the next class. So I apologize for that.
Okay.
So 12.
You just stopped a step early is I think what happened.
Yeah. 12 squared is 144. That breaks into 71, 73. 71 breaks into 35. 35 and 1. The 73 breaks into 36. 36 and 1. I'm making sure I do things right. So the inner square is 35 by 35. The outer one is 37 by 37. So I get 35 squared, yeah. So I get 12, 35, 37. I was having trouble walking and chewing gum. Okay. So the point I'm trying to make here is that when I do this correctly, is that we're going to get triples that are separated by 2 here, but occasionally we're going to get triples that revert to one of the triples that separate by 1 because they're all going to be even. And so the example for that was 100. When I started with 10 squared equals 100. Over here, I ended up with 24 squared plus 10 equals 26 squared. Sorry, plus 10 squared. My triple is 10, 24, 26. And that reduces to 5, 12, 13. So my point is that they're going to alternate, or there's going to be some triples that we get which aren't new because we saw them with the first algorithm. And then we're going to get some that are new because they're generated with the new algorithm. And what I want you to think about, and we can start off class before we go into groups briefly. What I want you to think about between now and the next class is tell me when we know we're going to get a new triple using this algorithm. And I'll send something written about that. So I'll summarize this briefly, then we'll start class. So anyway, sorry I screwed up on that and ended up confusing people. Okay. So that's all I got today. Hopefully I left you in a state of confusion. Hopefully you'll work yourself out. That's not a productive confusion. That's my fault. I apologize. But hopefully you get a sense of what's going on with this one. So, and again, we'll fix it up on Tuesday. So questions before I go, or I can stick around for a minute or two if somebody has questions, but I have something going on that I need to leave for in about 5 minutes. Okay, so I'll see you all on Thursday.